All right, this is Module 4, Lesson 9, where we will be writing linear equations. So we've already talked about some linear equations in one solution, ones that have infinitely many solutions, and ones that have no solution. So now we're going to, again, take a look at those trends that we've been noticing and that we've been talking about. So the first thing that we're going to do is we are going to share and talk about the algebraic representation for these types of equations that have either one solution, equations that have infinitely many solutions, or no solutions. So we already said that when equations have infinitely many solutions, that the left side is the same as the right side. Specifically, the coefficients and variables are the same, and so are the constants. So after distributing and combining like terms, those equations generally look like this, where we have a coefficient, a variable like x, and we're either adding or subtracting, usually another number, which we can use the letter b to represent. So the left side and the right side look exactly the same, right? That's what we have when we have infinitely many solutions. So for number 1, where we have the equation 5x plus 1 equals, right? And then we have this box, this blank that they want us to fill out. And then we have another box or blank over here. Oh, sorry, what happened? Technical difficulties. Oh no, where'd my thing go? Here we go. All right, we're back. Okay. So we are going to make up our own equation that fills in these boxes. So since we've already started about talking about infinitely many solutions, we're going to do that one first. I'm going to make up one. You can make up your own. So I'm going to say 5. Well, there's only one. Well, there's only one way. 5x plus 1 equals, well, what has to go in this box for it to be exactly the same? Well, of course, it's 5x and then plus, and what goes in this box so it's exactly the same? Well, it has to be 1. That's only one answer. We can't have anything else. So we're done with that. I should have probably scooched it down a little bit, but you get the point. All right, now talking about equations that have no solution. We talked about this yesterday, right? So equations that have no solution, we said that in the end, it's not going to make sense, right? You're going to combine the variables to one side, and then you're going to be left with something like 7 equals 5, which doesn't make any sense because obviously those are not equal. So how can we represent that algebraically? I'm just going to switch to a different color. That one wasn't really quite dark enough. Oh, actually I wasn't on the, that's because I wasn't on the pen. I was on the marker. All right. So how do we represent that algebraically? Well, that looks like ax, right? We have our coefficient, our variable x, plus b, plus a number, equals that same variable, that same coefficient, but instead of plus b, we have plus another number, plus some random d. So this is where we can make up a lot of different equations. So I'm going to make up one and you make up the others. So using number 1, 5x plus 1 equals 5x, but instead of plus 1, maybe I have plus 30, right? Whatever, something else in this place besides 1. So now you go ahead and make up a couple other equations that are going to also show no solution. Lastly, the one we haven't talked about yet is an equation that has one solution. Well, we've said we combine like terms, we use the distributive property, we do all of those things, and then we start solving. But what is going to give us that hint that tells us there is going to be only one solution? Well, obviously, it doesn't look like these equations, and it doesn't look like these equations, so it looks like its very own thing. So in this case, when we have only one solution, we still have our coefficient a with our variable x plus a number b, but that equals a different number with our variable x plus or minus a different number, right? So an example of that, I have 5x plus 1 equals, well, what's going to go here? I can pick any number. I can pick 3x plus, what's this? I can pick any number. I'm going to say -2, right? This might not be a pretty solution, but I'm going to go ahead and solve this, and I'm going to get only one solution. So I want you to now write your own example for one of these equations, right? What is going to go here? What is going to go here? So that you have only one solution. So finish filling out this table, write a couple of equations. All right, and then also try doing the same thing for number 2, right? Number 2 looks a little bit different because we have something else on the right side, right? We have this ax plus b. Oh, I didn't mean to do that. That was kind of ugly. Let me just erase this. We have this ax plus b. Well, what does that mean? Well, the first thing I always want to do is I want to distribute, right? So I can get a better sense of what is going on the left side. 2 times 4x. 2 times -3. So now I know what's happening on the left. What is the right going to have to be? And I could rewrite it just like we did the top if you like the boxes better instead of the A and the B, right? I could do the boxes better. So you are trying writing a few equations that have one solution, finding the one, there's only one that has infinitely many solutions, and writing a few equations that are going to have no solution. So pause the video. Oh, I wanted that to be red. Pause the video and try those, please. Okay. All right, after you've done that, hopefully you let me know if you have any questions. Hopefully you've shown me your work so far. Moving on to the next page. I feel like this page is pretty self-explanatory, but let's go ahead and read it together. Sean and Logan each find the number of solutions to the equation -4 times 5x minus 2 equals 2x plus 8 equals 8x. Sean did his work. He says the solution is 0. Logan did his work. He said the equation has no solution. Sean says there is only one solution, but Logan says there is no solution. Who is correct? Explain. Don't forget that explain part